So let's open up PuTTY to get onto our switch. So I'm connected via the console port. We'll click open here and press enter. It says, would you like to enter the initial configuration dialog? Of course we don't. Just like the router, we do not want to configure with that initial configuration dialog. What we want to do is configure it manually with a command line interface. Now, just like the router, the switch has user mode. To get past user mode, we type enable. That brings us to privileged mode. And then we can type in config T, and that brings us to configuration mode. At configuration mode, we want to set up our basic security, just like we did on the router. To set up our security, we need to configure line console 0. We need to put a password on it. I'm going to use the password of Cisco, and then we say log in to make sure that it asks us for that password. We can then do line VTY 0 through 4. Here we want to do password Cisco login. Since there is no aux port, we don't need to configure that. I'm going to change my switch name. We'll change it to TS switch for train signal switch. And we also want to configure a banner. So we'll use the banner, make sure I got the right syntax here, and we'll put our delimiting text in here as a £, and say this switch is owned by Train Signal, authorized use only. And last, we're going to set a privileged mode password. To do that, we'd say enable secret. Perfect. Let's verify our config. We'll go exit, exit, press return to get started, which is the enter key. It says the switch is owned by Train Signal. Got a little interrupted by our console message there, but the switch is owned by Train Signal, authorized use only. Password is Cisco. Ooh, EN. There we go. So we've put our passwords on our switch now. We have also changed our host name, and we've put the banner on. So that very simple process that went through a lengthy video on the router side, I went through relatively quickly here because it's the same process everywhere. What I've done is I configured a password to get from user mode to privilege mode. That was the enable secret. And then I've configured 2 passwords, one each for line con 0. So that way if I hook a rollover cable into the console port of my switch, I'm asked for a password. And then I've also set one on line VTY 0 through 4. Okay, so next thing next, let's set up Telnet access on this switch. Now, this is a layer 2 device. How on earth are we going to set up Telnet access to this device? Well, the way we do it is we actually set up an IP address on the device. And our switch actually does have layer 3 interfaces. So our layer 2 interfaces are called switch ports. Our layer 3 interfaces are called interfaces. So the switch ports we cannot assign an IP address to directly. However, we can assign an IP address to an interface. The way we set up interfaces on a switch is we actually create a layer 3 interface virtually. We're going to learn about this concept of VLANs in the VLAN video. However, to get started with the switch configuration, we actually have to assign an IP address to the VLAN interface. Oh my gosh, that sounds like craziness, right? Well, the way this works is that when we power on the router, all of these switch ports are automatically assigned to this thing called VLAN 1. All right, VLAN 1 is the base VLAN for all the switch ports. And essentially what that is it lets all the switch ports talk to each other on this one concept called a virtual LAN. Virtual LAN, in another aspect, another way to look at it, is a broadcast domain. So we can assign an IP address to a virtual interface on VLAN 1. Now, what's a virtual interface? A virtual interface is an interface that can behave like a real interface. It just doesn't have a physical network interface card attached to it. If that doesn't make sense, let's just configure it and you can see it in action. All right, so I've assigned the IP address of 192.168.10.10 to my PC. Let's assign an IP address of 192.168.10.2 to our switch. So I'll move into configuration mode. And in configuration mode, now what I do is I type interface VLAN 1. And what that will do is it will create a layer 3 interface for VLAN 1. Now what I can do is I can configure this just like a router interface by putting an IP address on it. And I can't just type the IP address in. We issue the command IP space address, and then I put the IP address that I want to assign to the device, which is 192.168.10.2, and we'll put the 24-bit subnet mask on there, 255.255.255.0. I'll issue the no shutdown command. And now my switch has an IP address on VLAN 1. Let's see if now I can telnet to my switch on that interface. So I'll open up another session of PuTTY. This time choose telnet as my connection mechanism and type in the IP address of my switch, which is 192.168.10.2. Here we go. The switch is owned by TrainSignal, authorized use only. Put in my password, type enable to get to privilege mode, and now I am at privilege mode. Here, just like on the router now, I can issue the show run command that will show me my running configuration file. The running configuration file is stored in RAM. All right, inside the running configuration file, let me scroll up here. You see that I changed my host name to switch. You see that I've set an enable secret. Oh my gosh, I grabbed the wrong spot here. Holy mackerel, all over the screen. Let's scroll back up here. Host name is set to switch. Enable secret is set here. We don't know what it is. It's all gibberish. I can tell you what it is. This translates to Cisco. How do you like that for decryption? So enable secret Cisco here. We look at my interfaces, and if you notice the interfaces, there's no configuration underneath them. This means that they are all in the up state and configured for VLAN 1, ready to use. Last, you can see my banner message here. We can see that my line console 0 and line VTY 0 through 4 have their passwords set. And then I also have interface VLAN 1 configured with an IP address as well. So we can do show run to show the running configuration. If I want to save this configuration now, so that when the switch boots up, it automatically loads a configuration file, just like the router, I issue the command copy running configuration to my startup configuration file. My startup configuration file on a switch is not located in NVRAM. It's actually located right on the flash. We still call it startup config though when we are using the copy command. Excellent. So that's the base configuration for the switch. We've put an IP address on an interface so that we can telnet to it. We've secured user mode and privilege mode access mechanisms. This is perfect. So what else are we going to do on this switch? Well, we're going to learn more advanced features in future videos of this, but for the time being, we are going to learn how the MAC addresses are learned by the interfaces. So we know that there is an ASIC on each switch port on this particular device. That ASIC reads the source MAC address and destination MAC address, and then that information is then used to make decisions about what to do with the frame. Well, those MAC addresses are all stored in the MAC address table. To do that, we issue the command show MAC-address-table. And what that will do is it'll show me all of the MAC addresses that are learned by my switch. And what it'll do is the switch will then tell me when I issue show MAC address table, so what VLAN the device is connected to, the MAC address of the connected device, the way it was learned statically or dynamically? So we can actually manually configure the switch port to have a MAC address associated with it if we want, and that's a static configuration. Or we can learn it dynamically, which means that it'll read it off of the frames that are arriving on the device. This is typically what we want, unless we have some specialized application. And then it has the last column here is the switch port that it is attached to. So the first 4 values here, these are switch values that the switch is using. And when we learn about spanning tree, we will talk about how these MAC addresses are used to determine how spanning tree operates. Spanning tree is way advanced for what we're talking about right now with switching. What we're interested in are the last 3 values. And those are the ones that are learned dynamically. So we have an address on Fast Ethernet 01, 02, and 03. Well, from the drawing that we looked at initially, my device is connected to Fast Ethernet 0/1. Well, how can I prove that? Well, I can prove that by looking at the MAC address of my device. To see that, I need to open up a command prompt. So I'll launch CMD, and I'll issue the command ipconfig. I have to spell it correctly. Get happy fingers here, they type too fast. ipconfig/all. And what this will do is it'll show me the physical address of my adapter. So here I've highlighted the physical address. This is the MAC address of my workstation. Let's compare this MAC address to the one that showed up in the switch. So the switch is showing 7011.248C DC5E. Here we have 7011.248C DC5E. Same MAC address. So my MAC address is currently connected to Fast Ethernet 0/1. I have other MAC addresses here. So the MAC address of the device attached to Fast Ethernet 03, 5CF9 DD772310. And then on Fast Ethernet 02, there's a different MAC address connected to that. So really on my switch, once I can look at the MAC address table, I can see what devices are connected to which ports on my switch. And that's all done with the MAC address. This wraps up my switch configuration video. We took a look at the MAC address as well as see how a switch configuration is nearly identical to a router configuration. There's a lot more to talk about with switches, and there's several more videos where we do switch configuration, and I really look forward to seeing you in these future Train Signal videos. Thank you so much.